boys and girls. My name is Miss Lisa, and we're here today at the Fayette County Public Library with a show called Science Isn't Scary. Today, we are going to be talking about water. Now, water has a surface to it, plus it can go super deep. Well, we're going to be talking about the tension that is created by water molecules today. So, all the water that's in a dish or in a bowl, down below that water is all those little molecules are being pulled together equally in all directions. But on the surface of the water, those molecules are pulled so tightly together that they create sort of a skin on the surface of the water. And this is what we call surface tension. And I've got 5 different things I want to show you today. Stuff that you can easily do at home with just some water and a few other items. So let's go over here. Let me show you a really cool thing you can do to look at and try to discover more about surface tension of water. So here I have a long pan. You're going to want to have a long pan. And you might want to print out some cute little characters. I printed out frogs because frogs live in the water. Put a little hole and give it a little slit. Okay. What we're going to do is have a race. Now, if I just lay these on the water, the paper will get soaked up and it will just sink. But if we add some dish detergent, it will break the skin. It will break the surface tension, and these little frogs will go all the way across the water. So let's go ahead and try it. So I'm going to lay them right here and scoot them away from the edge just a little bit. I have 2 little eyedroppers with some Dawn dish detergent in it. And ready? Whoops. Oh, they must have gotten 2. Okay, so they're not working, folks. Let's get them out. Try again. This is what science is, trial and error. Now, this morning when I did it, it worked just perfectly, so I'm not sure what happened this time. I've got more frogs. I need to do it faster. Don't let them get so wet. So we're going to squish them. What happened? Oh, my goodness. It's not going. Go, 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 go. I am so disappointed, boys and girls. This morning it did just perfect. I don't understand. I've got one more I can try. This little frog, let me make sure I have enough Dawn. You just never know what's going to happen when it comes with science here. Oh, I wanted to show you this so bad, boys and girls. It works so cool. Okay, so in they go. I didn't put it on the little hole. And now this Dawn's not coming out. Oh, boys and girls, I am so sorry. I want it to go. Go. Oh. Go. Go, 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 go. All right, well, I am sorry. This worked this morning. So you might need to try this at home because it does work. They do scoot across and they can have a race. What did I do wrong? That makes me sad. All right, let's try another one. I hope they don't all bomb today. All right, so we're going to use some toothpicks. All right, and we're going to lay very gently, because you don't want to try to break that surface tension. You're going to lay the toothpicks on the top of the water very gently in a triangular shape. And I'm going to add 1 little drop. Well, it's not looking like a triangle. I'm going to add a drop of, and there they go. Did you see those toothpicks? They went and separated because that Dawn broke the surface tension. All right, let's come over here to this one. And this is something else you can try at home. Get some pepper and just put it across the skin of the water there. And I'm just going to do 1 little drop of water. Of dish soap. And boop, there it goes. That's what the frog should have done. They should have skittled across the across my pond. Okay, so the surface tension has been broken, and the pepper goes off to the side. Now, this is the tricky one, boys and girls. Paper clips. Can you make a paper clip float? So, Even if I lay it in there super gently, it sinks immediately. I even thought, well, what if I increase my space of my paper clip and make a circle? Will it? Oh, look. That just flips for a little bit. Look at that. Well, that's one way you can make a paper clip float. And there's another way that you can make a paper clip float, and I'm hoping that this will work for you. Wow, that's really staying on there nicely. That's a surprise. That did not do that for me earlier. So we're going to break the surface tension by putting this piece of paper on the skin there and laying the paper clip on top. Now, here's the tricky part, and it has worked for me twice before. You just want the paper clip to gently slide off of the paper, and it will stay floating on the surface. But it doesn't always work. Oh, come on, paper. Oh, it's almost doing it. Let go, let go, let go. There it goes. It did it the first time. Look at that. You can make a paper clip float when normally it just sinks right to the bottom. Look, I actually have two of them still floating. Amazing. Yay, one of them works today. Cool. All right. Another thing you can do is that you need to have some type of an eyedropper, and you need some coins. Now, I am going to show you that the water is going to adhere to one another. These little water molecules are going to stick together on the surface of this penny. Now, I like to usually count how many bubbles I've made. But see, look at it. It's just making this big dome of water on top of that penny. And if you just do it very carefully and just drop one penny at a time, I've gotten up to 30 little droplets on a penny before. Look at it. Do you see the little bubble? Now, eventually, you'll get too many molecules, and it will break the surface tension, and the water will go spilling out. Do you see that dome? Isn't that cool? Let's see if we can get a couple more. I wish I had started counting. Here we go. Is it going to break the surface tension? Is it going to spill over? Yep, there we go. Now, I also have other coins here. If you'll notice, I also have a dime and a nickel and a quarter. Now, boys and girls, if I did the same experiment on a dime, would there be more or less water droplets? And hopefully you said less, because the surface area of the dime is smaller than the penny. There's going to be more water droplets on these two coins because they're bigger than that. So try it at home, boys and girls, and see once how many drops of water you can get on a penny. Now, you might even be able to record your results and make a graph. That's really cool. You know what I'm going to do? I've got one more frog. I am going to see once if he won't move. I'm just wondering if, since there's already detergent in this one, if there's already Dawn in there, that's why it didn't move. So, I'm going to stick him right here. And I don't know if it's going to work, but I sure did want it to. Maybe I'll use this kind of droplet instead. So we're going to stick our frog on the top. And there he goes. So maybe you can only do it once in a bowl. That's an experiment. Obviously, this one worked, and that one didn't. I had tried it earlier in there, so the surface tension must already be broken because of the detergent that's in there. So this one worked great, boys and girls. All right, water tension, or the surface tension of water is something that's really cool and fun to play with. So I hope you will try these at home. It's always fun to experiment, and water is very available at your house, so try it and see what you can come up with. All right, boys and girls, I hope you'll see me again next Tuesday at 2:30 for another cool big concept of science. Bye-bye.